Welcome to this lesson video. In this lesson video, we'll be looking at kinetic frictional force and normal force. Let us start. We look at different scenarios on how to calculate the normal force together with kinetic friction. Now, it is very important for us to know how to calculate the normal force in order for us to continue and calculate the kinetic frictional force. Now, what is the normal force? By definition, normal force is the force or the component of a force which a surface exerts on an object in contact with it and which is perpendicular to the surface. I repeat, normal force is the force or the component of a force which a surface exerts on an object in contact with it and which is perpendicular to the surface. Now, using a picture form, what is normal force? Suppose we have this flat surface. This is our object. We know that a certain object with a certain mass exerts a gravitational force onto the surface, and then in return, as a result of action-reaction pair, the surface also exerts a certain force to the object. So the force which is exerted by the object to the surface, it's our gravitational force or weight. And then the force exerted by the surface to the object, it's what we call the normal force. So this is the direction of the normal force exerted by the surface when we look at an object on top of a flat surface. Now, there is an equation on how to calculate this certain normal force. Let us start with the first scenario. A flat surface. The direction of the normal force will be this direction as a result of reaction of our gravitational force. Now, what is the equation of normal force when we're dealing with this certain scenario? Now, before we can get to normal force, the equation to calculate the gravitational force is the product of the mass of the object multiplied by the gravitational acceleration. Now, in this case, we can see that the normal force is oppositely directed force of gravitational force. So it simply means that in terms of magnitude, the magnitude of gravitational force and the magnitude of normal force are equal. In that case, the only difference is the direction. We can see that normal force is oppositely directed force of gravitational force. So if this is the equation of gravitational force, it means the equation of normal force is the product of the object's mass and the gravitational acceleration. If you consider upward as positive, it means downwards it will be negative. But since I generated this equation, you can see that all the magnitudes are positive, so it means the opposite direction will be negative. So for the purpose of notes, how do we calculate normal force looking at an object on top of a flat surface? This is the equation. Let us look at an examples. What is the normal force of this certain object which has the mass of 5 kg? The mass, we have 5 kg. The gravitational acceleration, we have 9,8. And then 5 multiplied by 9,8 is 49 newtons. The SI unit is newtons because normal force is also a force. Example number 2. We have an object. The mass is 30,000 grams. What is the normal force exerted by the surface onto this object. Before we do that, we need to convert the grams to kilograms. Now, how do we convert? So from grams, when we want to convert from grams to kilograms, we divide by 1000 or we multiply by 10 to the power negative 3. So 3000 divided by 1000, it's simply 3. Then we go back to our equation. Our mass is 3. We have 9,8. Three multiplied by 9,8, the answer should be 29,4 newtons. Feel free to pause the video, attempt this question, calculate the normal force, and play the video to verify your answer. So the equation is, then we have normal force 0,3 multiplied by 9,8. So 0,3 multiplied by 9,8, the answer should give you 2,94 newtons. Now the second scenario we're going to look at is this one, an incline. How do we calculate the normal force looking at an incline surface? Now what is very important is to know that gravitational force is always vertically downwards. It doesn't matter whether we are dealing with a flat surface or an incline. You must know that the direction of the gravitational force is always vertically downwards. Now normal force, it should be perpendicular to the surface. There should be 90 degrees between the surface and the normal force. So you can see that the direction of the normal force depends on the surface. Now in this case, remember Fg is equals to mg. In this case, the normal force cannot be equals to mg. Now we normally say, let us go back to the previous scenario. We normally say normal force doesn't have a specific equation. All it does, it adopts an equation of the force which forms 180 degrees with it. So if this is our Fg, we can see that the angle between Fg and the normal force is 180 degrees. So whatever force that forms 180 degrees with the normal force will absorb that equation. So we know that Fg is equals to mg. So since normal force and Fg, they are 180 degrees apart, so it means normal force will also have mg. Let us go back to this one. Now you can see that the angle between the normal force and the gravitational force is no longer 180 degrees. So in this case, our equation for normal force is no longer 180. Now let us explain this furthermore. So this is our normal force. This is our gravity. Actually, it's gravitational force. Now let us look at this. Forces. We all know that we have components of forces. For each and every force, we have the vertical component and horizontal component, which we say vertical component it's Fy, and then horizontal component it's Fx. Now let us try to resolve Fg in terms of its components. This will be our Fy, the vertical component of Fg. So we can say Fgy, and then it depends whether you use tail to tail or tail to head method. If you're using tail to head method, our gravitational force, actually our second gravitational force or the second component, will be here, and then this red one we say it's Fgx. Fgx it's always parallel to the surface. If we use tail to tail method, our Fgx will be here. Now looking at this, we can see that the angle between the normal force and the Fgy is 180 degrees. Now what is left? We need to know the equation of Fgy. Now this is taking us to our next part of this lesson video, which is the components. We have Fg, Fgy, and Fgx. Components of Fg. Now these are the equation. Our Fgx is equals to Fg sine theta, where we know that Fg is equals to mg. So when we expand this equation furthermore, we have Fgx is equals to mg sine theta. So write this equation down. Is the equation to calculate the horizontal component of gravitational force. Our Fg vertical is Fg cos theta. Fgy, we know that Fg is equals to mg cos theta. This is the equation to calculate Fg vertical. Now this angle, going back to our drawing, the angle of which we are going to substitute here, also on cos theta, it's the angle of the incline. So whatever angle you have here is the one we are going to use to calculate our components. So let us go back to this drawing. Now we want to know what is the equation to calculate the normal force in this situation. Now we can see that the force which forms 180 degrees with the normal force, it's Fgy. So it simply means that our normal force will be mg cos theta. This is the equation to calculate the normal force of an object which is on top of an inclined surface. This is the second scenario of normal force. Let us look at examples. Suppose we have this scenario whereby we have an object of 2 kg on top of an incline. How do you calculate the normal force? So N is equals to Fg cos theta. N is equals to mg cos theta. And then we have N is equals to, the mass is 2, 9,8 cos 30 degrees. Now punching this on your calculator, the answer should give you 16,97 newtons. Our second example, 5 kg block on top of a 45 inclined ram. How do we calculate this? So normal force is equals to mg cos theta. Normal force is equals to 9,8 cos 45. The answer should give you 34,65 newtons. This example is a bit different. You are given the normal force, you are given the mass, and then we need to calculate the angle of the incline. So we have normal force is equals to mg cos theta. We have this, we have this, we have this. We are looking for this. Now our normal force is 49. Our mass is 10. Our acceleration is 9,8 cos theta. We divide both sides by 10, 9,8, 10, 9,8. We know that this will result into 1. 1 multiplied by cos theta is cos theta is equals to 49 over 10, 9,8. Then how do we solve for theta? The inverse. So theta is equals to cos 49, 10, 9,8. We simply punch this onto the calculator. The answer is 60 degrees. Our next scenario is a bit challenging for most of learners who are taking physics. We have a flat surface, and then we have a certain applied force at a certain angle. This force is not parallel to the displacement, as you can see. There is an angle between the reference line, which is parallel to the displacement, and that particular force. Now in this case, we no longer take the force which is 180 degrees with the normal force. We can explain this in detail. Now what happens is that we look at the vertical motion of the object. We know that when you talk about horizontal motion, we are talking about left and right motion of the object. Then when you talk about vertical, we are talking about up and down of the object. Now a simple question. When you apply a force at a certain direction, actually this direction, what will be the direction of the block? What will be the acceleration of the block? We can see that the block will accelerate this direction. Do we have any up and down motion of the block? No, we don't. Now, when it comes to generate the equation of the normal force in this situation, we are going to look at the up and down. We isolate any forces which are parallel to the displacement of this object, and then we look at all the forces which are perpendicular to the displacement, which is up and down motion. Now we can see that if we have this particular force, then it means we have its components, which is vertical and horizontal. So this is F. If this is F, then this will be our Fx, and then this will be our Fy, the components of this force. We also have this gravitational force, and then we have our normal force, which is this direction. Now remember, when we resolve a force into its component, we no longer consider the original force. We only look at its components only. Now in this case, let us derive the equation of the normal force from Newton's second law equation. But then, we don't look at all the net force. We specifically focus on the Y, vertical forces, the mass, and then also its acceleration, which is up and down. Now in this case, we said that the displacement of the object is this direction. There's no up and down motion. So it simply means that the acceleration, our AY, acceleration of up and down, is simply 0 because this object doesn't accelerate up or down. There's no vertical acceleration. Don't confuse this acceleration with the gravitational acceleration. Now our equation will be F net y is equals to m, where we see acceleration y is 0, and then the mass of the object multiplied by 0 is simply 0. Now F net y, we look at all the forces which are vertically orientated. So in this case, we can see that the first force is gravitational force, which is downwards. The second one is our normal force, which is upward. And then the third one is our Fy. We can't take Fx because it's parallel to the displacement. It's not F. It's actually not vertically orientated. So we all know that F net means the sum. Now we take up as positive, and then we take down as negative. So we have Fy, which is positive, plus normal force, which is also positive, plus, remember, F net is the sum, inside the bracket negative, Fg, since it's going down, it's equals to 0. Now simplifying the brackets, we have this is equals to 0. Now remember, this lesson video is based on normal force. We are looking for the equations to calculate normal force. Now it simply means that we have to transpose this to the other side. We make normal force the subject of the formula. We also transpose this to the other side. So transposing, we are left with normal force this side. Then Fg will be positive minus Fy. Now before we continue, remember, on an incline we talked about the components, then we talked about the equations of the components. Now flat surface and incline, the components are a bit different in terms of equations. So if this is f, we know that this will be our fx, this will be our fy. In this case, whereby we have a flat surface and then a certain force applied at a certain angle, it's a bit different when it comes to trig ratios. Our fx is equals to that particular force multiplied by cos theta. You can see that it's a bit different. Fx on an incline, it's sine. Fx on a flat surface, and then we have a force applied at a certain angle, it's cos. So it means Fy will be what? F sine theta. Also write these equations down. This is the equation to calculate the components when we look at a flat surface and a force applied at a certain angle. Now expanding this equation furthermore, normal force is equals to, we know that Fg is equals to mg. So where we see Fg is equals to mg. Where we see Fg, we can substitute by mg minus, remember flat surface, Fy is equals to F sine theta. So it means where we see Fy, you can substitute by F sine theta. This is the equation to calculate the normal force on a flat surface, and then we have a force applied at a certain angle. Let us look at the first example. We have this object which is 60 kg. Then there's a force applied onto this object which is 20 newtons. The angle is 30 degrees, and then we are looking for the normal force. Remember, normal force, it's equals to, actually let me do this, normal force plus Fy is equals to Fg. Then normal force is equals to Fg minus Fy, and then we have normal force is equals to mg minus F sine theta. Then we have normal force, it's equals to the mass, it's 69.8 minus 20 sine theta. Then this should give you 578 newtons. The next part of the example, we are given the normal force, which is 98 minus 30 root 2 newtons. In decimal is 55.57 newtons. The angle is 45 degrees. The mass is 10 kg. And then we are looking for the force exerted on this object. So we have normal force plus Fg. No. So normal force plus Fy is equals to Fg. Normal force is equals to mg minus F sine theta. So the normal force, we are given that it's 98 minus 30 square root of 2. It's equals to, the mass is 10, 9.8 minus F sine 45. So we have negative F sine 45. It's equals to 98 minus 30 square root of 2 minus 10, 9.8. We divide both sides by negative sine 45. We know that this will result into 1, and then we are left with f is equals to 98 minus 80 square root of 2 minus 10 9,8. This will be negative sine 45. Then the answer should give us 60 newtons. The next part of this lesson video is kinetic frictional force. We need to know the definition of kinetic frictional force. Kinetic frictional force is the force that opposes the motion of a moving object relative to a surface. Now, in most cases, we confuse the motion of the object and the applied force. Kinetic friction is against the motion of the object, not the applied force. Now, how do we describe this using pictorial form? So suppose this object is moving this direction. Kinetic frictional force will be this direction. If the object is going this direction, kinetic frictional force will be this direction. The object is moving up, kinetic frictional force will be this direction. And then there is this situation whereby we have this block experiencing a force this direction, is being pulled up, but the displacement of the object is going this direction. It's been pulled up, but the object is going downwards. What is the direction of the kinetic frictional force? This is the displacement, then this is the force. The kinetic frictional force will be this direction. Remember, it's opposite to the displacement or the motion of the object. Now let us look at equations on how to calculate this kinetic frictional force. We have this object, it's moving this direction. The mass of the object is 10 kg. The coefficient of the surface is 0.1. Now, how do you calculate the kinetic frictional force? So the direction of the kinetic frictional force is this direction. Now we need to calculate. What is the equation before we go to calculation? What is the equation to calculate the kinetic frictional force when we have an object on top of a flat surface, and then we need to calculate the kinetic frictional force? What is the equation to use it? The equation is Fk is equals to the coefficient of the surface multiplied by the normal force. The very same normal force we've been talking about. Now, if you know the equation of normal force on a flat surface, then it will be simple for you to calculate the kinetic frictional force. The normal force is equals to mg. Now, it simply means that the equation to calculate the kinetic frictional force is the coefficient multiplied by the mass of the object multiplied by the gravitational acceleration. This is the equation. Now, going back to our scenario. So it means the equation we are going to use is Fk is equals to coefficient multiplied by normal force. Then expanding this equation furthermore, we have coefficient multiplied by the mass and gravity. Now the coefficient is 0,1, our mass is 10 kg, our gravity is 9.8. Punching this on the calculator, the answer should give you 9.8 newtons. So you can see that we only need the coefficient of the surface and the mass of the object in order for us to calculate the kinetic frictional force. So in this case, we are given the kinetic frictional force, we are given the mass of the object, and then we are looking for the coefficient of the surface. Now the equation is Fk is equals to coefficient multiplied by normal force, and then expanding this furthermore, we have mass and gravity. Then we can see that our Fk is 39.2 is equals to coefficient, the mass we have 29.8. Then we divide both sides by 29.8, 29.8. Then this will result into 1. Then our coefficient is equals to 0.2. Now somehow the coefficient doesn't have an SI unit. Why? We have Fk is equals to coefficient multiplied by normal force. And then when we make the coefficient the subject of the formula, this will result into 1 multiplied by coefficient is coefficient, it's equals to Fk over normal force. Now we all know that an SI unit of a particular or a certain physical quantity consists of the quantities which we have within the equation. So in this case, what is the SI unit of kinetic friction? It's normal force. All over the SI unit of normal force, it's also newtons. Actually, the SI unit of forces kinetic friction is Newton. The SI unit of normal force is also Newton. So Newton divided by Newton, this will result into 1. That is why the coefficient doesn't have an SI unit. Our next example is this one, whereby we have an object on top of a ram. Now we know that the kinetic friction is this direction, but before we look at this particular example, let us look at an equation. Now if you master all the equations of normal force, then it's very simple to calculate the kinetic friction. This is the actual equation of kinetic friction. So what is different? It's this normal force. It depends on the scenario that you have, whether it's a flat surface, it's an incline, or it's a flat surface whereby there is a particular force applied at a certain angle. So just remember the equation of normal force in this situation, then you're good to go. Now remember, normal force in this situation is Fg cos theta. So when we expand this, we have mg cos theta. So it means our kinetic friction will be coefficient multiplied by mg cos theta. This is our normal force. It's this N. Now let us go back to this scenario. So Fk is equals to coefficient multiplied by normal force. Fk is equals to coefficient multiplied by mg cos theta. Fk is equals to coefficient, which is 0.45. The mass is 20 kg cos theta. And then the answer should give you 7.79 newtons. Our next example, we have this block 80 kg, and then we have kinetic friction. We are also given the angle of an incline. Then definitely sure you're looking for the coefficient. The equation, normal force, coefficient mg cos theta, and then we are given that the kinetic friction is 166.331 is equals to coefficient, our mass is 80, 9.8 cos 45. Simply divide both sides by this. This will result into 1 multiplied by coefficient, it's coefficient. And then punching this on the calculator, the answer should be 0.3. Our next example is this one. But before we look at this, let us generate the equation. Remember, the equation is Fk is equals to coefficient multiplied by normal force. Fk is equals to coefficient. Remember the normal force in the situation. The equation is mg minus it's mg minus f sine theta. So this is the equation to calculate the kinetic frictional force. Now in this situation, we start by writing the equation, normal force, and then we have Fk is equals to coefficient multiplied by mg minus f sine theta, and then we have Fk is equals to 0.3, and then the mass, let me use a square bracket. The mass we have 100, 9.8 minus 200 sine theta. (0.3) 100 9.8 negative 0.3 200 sine theta. The answer should give you 264 newtons. Now that's it for this lesson video. I hope this was very helpful. This is Baula SJ. Thank you very much.